In this video, we're going to be taking a look at another example of solving a quadratic inequality using algebra. So what we're going to do first is we're going to attempt to find the x-intercepts of this quadratic inequality, because at the x-intercept, that's where your quadratic function, or really any function, is changing from positive to negative or from negative to positive. So if we can find the x-intercepts, then that's going to help us figure out what values we're going to be able to test in the intervals, so that we can test whether those intervals are positive or negative, meaning our graph is above or below the x-axis. So before we can do that, we need to make it so that this inequality is all on the same, like all of the values are on the same side of the inequality, so that we have a quadratic in standard form. So I'm going to add 20 to both sides. So when I do that, we get the inequality negative x squared plus x plus 20 is greater than or equal to 0. So what we're trying to figure out is, where is this function greater than or equal to 0? Where is it above the x-axis? So let's find the x-intercepts for this function. So again, remember, when we're dealing with x-intercepts, we're just going to set this up as an equation and solve that way. So negative x squared plus x plus 20 equals 0. So we need to try and factor this. So we're looking for factors of negative 1 times 20, so negative 20, that add to be 1. Factors of negative 20 that add to be 1. Negative 4 and positive 5, I think, work. So let's set up our factoring. So we need to factor this by grouping. So we have negative x squared minus 4x plus 5x plus 20 equals 0. Now the reason we can't just use the shortcut is because the leading coefficient isn't a positive 1. So we have to factor this by grouping. Then you group these and you group these and you factor. So you find the greatest common factor for each group. So the greatest common factor of negative x squared and negative 4 is negative 4x is going to be a negative x. So factoring out negative x, we get x plus 4. The leading term is positive, so we're going to factor out a positive value. The greatest common factor here is 5, so factor out a 5. We get x plus 4, and that equals 0. So this quantity and this quantity are the same, so we can factor that out, x plus 4. And then what's left on the outside becomes our other factor, negative x plus 5 equals 0. Now, using the zero product property, we can set each of these equal to 0 to find our x-intercepts. So we get subtract 4, we get x equals negative 4. And then add x, we get that 5 is equal to x. So our x-intercepts happen when x is negative 4 and x is 5. So let's make a number line and figure out what values we can then test to figure out where our graph is greater than or equal to 0. So here is our number line at negative 4 here and at 5 here. So let's go ahead and test values. So in between, so picking any value in between negative 4 and 5, I'm going to pick 0. So if x equals 0, what is true about our function? So let's substitute it in. So it's negative 0 squared plus 0 plus 20. That's just 0 plus 0 plus 20, which is 20. And that's a positive value. So in this interval, all of our values are going to be positive. Let's pick a number to the right of 5, maybe just 6, if x is 6. So we have the opposite of 6 squared plus 6 plus 20. This is 36, but we take its opposite, so negative 36 plus 6 plus 20. That's negative 36 plus 6 is negative 30, plus 20 is negative 10. So this is a negative value. So to the right of 5, we get negative values. And then if x is less, let's pick a number less than negative 4, maybe negative 5. If x equals negative 5, what do we get? So this is the opposite of negative 5 squared plus a negative 5 plus 20. Negative 5 squared is 25, but we're taking its opposite, so negative 25. Minus 5 plus 20, that's negative 30. Negative 30 plus 20 is negative 10. So again, it's negative here. Now we want to know where this graph is greater than or equal to 0. Greater than or equal to 0. So that means where it's positive or equal to 0. And we know that at negative 4 and at 5, our graph is equal to 0. So in this one, at negative 4 and at 5, since it's equal, and this is a greater than or equal to, we're going to have a closed circle here because they will be included in part of the solution set. And then this being positive is saying that everything in between those values is part of the solution set. So our solution is all of the values in between negative 4 and 5. So negative 4 less than or equal to x less than or equal to 5. So it's the set of all x such that negative 4 is less than or equal to x is less than or equal to 5. That's our solution set. If we were doing this in interval notation, since it's closed, it would be brackets at both ends. So it would be negative 4 comma 5, and then brackets, negative 4 comma 5. That would be the interval notation for the solution set in this problem.